Welcome to this month's tip. This is the last tip in a sequence of 3 updated tips based on the July 2003 tip titled Patterns of Features Used to Establish Datums Are Tricky. In Part 1 and 2, we discussed several different ways to use patterns of features to establish a datum. In this tip, we are going to explore what happens when our features are referenced at MMB, and why you may not need to use a pattern to establish a datum. Patterns of Features Used to Establish a Datum, Part 3 of 3. As we discussed in Part 1 and 2 of this tip, the Y14.5 standard tells us we can use a pattern of features to establish a datum. For this tip, we are going to explain why that isn't needed if the datum feature is referenced at MMB. Here we have the same part, called housing, that we looked at for our last tip. In this tip, we changed datum feature B, which is this pattern of 2 holes, to be referenced at MMB. That means, when establishing our datum reference frame, datum feature B will be at MMB instead of RMB as it was in Part 2 of this tip. Remember that the MMB modifier that follows each datum feature B reference is an instruction that tells us how to construct the datum feature B simulator. Because of the MMB modifier, we know the datum feature simulator for B will be 2 cylindrical pins perpendicular to datum A within tooling tolerance and fixed at the MMB size for datum feature B. The MMB for the 2 datum feature B holes is diameter 6 minus 0.1 minus 0.2, which equals diameter 5.7 millimeters. You may remember in Part 2 of this tip that the datum feature simulator for B was an expandable pin. That is because in Tip 2, datum feature B was referenced at RMB. You may wonder how this affects the way datum feature B fits on the datum feature B simulator. If the 2 holes are not made at their worst case size, orientation, or relative location, then there will be some slop in the fit of that particular part on the datum feature simulator. This will allow shift between the part and the datum reference frame. You may be thinking, what if datum feature B was not a pattern of holes, but instead one hole was datum feature B and one hole was datum feature C? Well, because of the MMB modifier, that would be applied to B and C. It would not change the way the part fits on the simulator, so you could make this change with no consequence. Let's take this one step further. If we were to add 2 additional pins at their virtual condition sizes to this gauge, the datum feature simulator set is now a functional go gauge. What are those virtual condition sizes? Diameter 6.25 millimeters for the 3rd mounting hole and diameter 9.6 millimeters for the center hole. What does this mean? If a part will go onto the gauge, the 2 diameter 6 millimeter holes and all the other features that are toleranced at MMC relative to the datum reference frame AB do not violate their maximum material boundaries. If you then check all the local sizes of each feature and they are in spec, you are done with the inspection of the part and it is good. This is called the surface method of evaluation. This shows us that, as far as the gauge is concerned, it doesn't matter which features are datum features and which features are toleranced relative to the datum reference frame. So, from a design and function standpoint, we can take this one step further and have only one datum feature reference, and that is A. In this version of our design, the rule of simultaneous requirements ties all the tolerances that reference datum feature A together. We can use the same gauge discussed in Figure 5C. Man, that really made this drawing simple. If you need a refresher on the rule of simultaneous requirements, we have several tips that deal with this subject. This sequence of 3 tips has discussed how and when to use or not use patterns of features to establish a datum. Watch for our next tip to further your knowledge of GD&T. Remember, at Tec-Ease, GD&T rules. See you next tip.